Assalamu alaikum wa rahmatullahi wa barakatuh. Our cherished viewers, once again we've met for MTA Mathematics. God willing, last time we were able to draw the curtains down on numbers and numerals. Today we are going to start a new topic, which is sets. A new topic, which is sets. Sets. For the purposes of this topic, students should be able to know the types of sets and its definition. Also, should be able to brainstorm the definition of sets. So, what is a set? Way back class 6, what did we know about sets? Now, let's take two examples of a set and see which one can be used or can be used to define sets. Okay, let's take these two examples or two writings on the board. Number one is a JHS 1 girl who is dark. 2, the shortest dark JHS 1 girl. Now, let's say you've been asked to enter into a school. Go to the JHS 1 class and bring a dark girl. The next one also says that go to the JHS 1 class and bring the shortest dark girl. Which one do you think will be easier? Is it 1 or 2? You could see that for 1, the student or the person enters into the school, gets to the JHS 1 class, and might find about 2 to 3 dark girls. So he or she will be confused about which one to choose. But the second person, where the sentence reads, the shortest dark JHS 1 girl. So here the student or the individual will just bring out all the dark girls and choose the shortest of them. Okay. So this tells us that a set is a collection of a well-defined object of the same kind. A collection of a well-defined object or a collection of objects of the same kind. So when the object is well-defined like the 2, you'll be able to obtain it. Or objects of the same kind, like a dozen of babies, a crate of eggs. All those are sets. Okay. A set is denoted by a capital letter. So this, if it was to be put into a set, this is how it should be. A, the shortest. So that is how to write it when it is a set. The shortest dark JHS 1 girl, that is A. Now, let's look at the types of sets. Now, we should have a set of prime numbers, a set of even numbers, a set of odd numbers, a null set, an equivalent set, an equal set, a universal set, union of sets, intersection of set, finite set, infinite set and other examples or other types. Now, I'm going to give some few examples of sets on the board, and we shall use our definitions of the types of sets to get the correct one. Let's say if I have A, B, C, D, E, G, H, okay. I guess we will be able to remember some of the types of sets. Okay, we have a set of whole numbers. And we said a set of whole numbers are sets which starts from 1 and ends at infinity. Then we have a set of counting numbers starts from 1 and ends at infinity, whilst a set of whole numbers starts from 0 and ends at infinity. Then we have a set of even numbers which starts from 2, 4, 6, 8, 10, and also ends at infinity. And we have a set of odd numbers which also starts from 1. We go to 3, 5, 7, 9, 11, and also ends at infinity. We have a set whose last member cannot be found, and we call this set a finite set. It's a set whose last member cannot be found. And those ones which last members can be found are called a finite set. And those whose last member cannot be found are called the infinite set. And we have a set which does not have any element. We call that set a null or an empty set. The one with only one member or element is called the unit set. The unit set. Okay, looking at the examples on the board, what A? How can you classify A? Which type of set is A? It is starting from 1 and is ending at 4. Look at B, starting from 0 and ending at 3. So, from the definitions I just mentioned earlier on, we said the ones which start from 0 are whole numbers, and the one which starts from 1 are counting or natural numbers. So looking on the board, A here is a set of counting numbers less than 5. B, a set of whole numbers less than 4. C and D looks the same, almost the same. There is 2 here, there is 2 there, there is 3 here, there is 3 here, there is 5 here, there is 5 here, there is 7 here, there is 7 there, but there is 11 here, but here is 9. Okay. A student can say C are prime numbers, or D is also a prime number. But the good student will just look at the definition of a prime number. which in our previous lesson we said they are numbers which has only two factors, the number itself and 1. So looking at 9, 9 is not a prime number, but 9 is a what? Composite number or an odd number. So looking at this C giving us 2, 3, 5, 7, and 11 makes C a set of prime numbers less than 13. Then this also is a set of odd numbers less than 11. Let's add 1 to it so that it makes it perfect. What about E? We have 2, we have 4, we have 6, we have 8. This, a student can write multiples of 2 less than 10. That one too is right. But for the types of sets, we can say that it is a set of even numbers that is less than 10. Okay, F has a curly bracket without any member or a cancelled 0. This is a null set. Set or an empty set. And this one has only one member, G. It's called a unit set. Then H is called infinite set. As we said, a set whose last member cannot be found, we call it infinite set. So looking at H, we've given infinity 3 dots. This means it continues. So since this last member cannot be found, it is an infinite set. All sets whose last member can be found are what? Finite set. So looking at A, B, C, D, E, and G can all be finite set because the last member here is 1 and the first member here is also 1. The last member here is 8, that of D is 9, that of C is 11, that of B is 3, and that of A is 4. So it makes it finite set. That is set A, B, or C are all finite sets. Now, looking at this odd number or odd numbers, somebody would ask, what is an odd number? What is an odd number? An odd number is different from a set of odd numbers. An odd number is a number that can be divided by 2, which gives an answer which is not a whole number. That is an odd number. A number that can be divided by 2 and the answer it produces is not a whole number. But what is a set of odd numbers? A set of odd numbers are numbers that starts from 1, 3, 5, 7, 9, 11, 13 to infinity. Now, what is an even number? An even number is a number that can be divided by 2 without a remainder. So this means that 2 can divide that number exactly without a remainder. Okay. Since we now know some of the types of sets, we are going to also take some 3 sets which is going to help us with some calculations. We call those sets the universal set, the subset, and the complement of a set, and the union. So universal set. it is denoted by this or that. That is the universal set. And this set is a set under discussion, or it's a set that contains all the elements of the other set. Contains all the elements or members of the other sets. Then we have a subset. And this set is a set whose members or all its members can be found in another set. All members belonging to another set. It is denoted by this or that. It is denoted by this or that. An example will be A, 1, 2, 3, 4, and B, 3, 4. So here A will be the universal set and B will be the subset of the A, because all the members, which is 3 and 4, can be found in A. So therefore, we will say B is a subset of A. Now, we need to know union of sets. Union of sets. This deals with putting two or more sets together to form one bigger set. But taking into consideration where we start listing from the least number to the biggest number. But where a number appears in both sets, it is repeated only once. It is repeated only once. This also is denoted by this, U, meaning union. Put them together. Put together. Put together. Okay. So an example can be E, 1, 2, 3, F, 3, 4, 5. And you'll be asked, find E union F. This means that put these two sets together. Put them together. So therefore, E union F will be equal to a curly bracket opened. As we said, we are putting them together. Start from the smallest number and end with the biggest number. But when a number appears in both sets, repeat it once. So looking here, 1 should be the first number. 2, 3 is here, 3 is there, but should be repeated only what? Once. Then 4 continues, then we have what? 5. So union of sets means put them together. You should put them together. We should also know the intersection of sets. This is denoted by, and this means let's use belongingness, or let's use common. Common element or members of both sides or in both sets. Intersection of set means compare the 2 or 3 sets or more. What element is which is common in both elements is what you put down. Is what you put down. If there is no element which is common, then the answer becomes a null set. That is why we learned a null set today. So let's say, looking at the first example at the unions of sets, let's use the same example. So if we are being asked to look for, let's say this is I, so this is II, E intersection F. E intersection F. This means what element or member belongs to both sets. Looking at E and F, we could see that 3 belongs to what? Both sets. So this means that 3 is the answer. 3 is the answer. Let's take another example. A, 1, 2, 3, B, 6. So looking at this, we said find A intersection B. So when we compare the elements or the members in both sets, 1 is here, 1 is not there. 2 is here, 2 is not there. 3 is here, 3 is not there. If you compare 6, 7, 8 also to A, there is nothing there. So this makes A intersection B a null set. So you just write, therefore, A intersection B is equal to a null set. Either you write this or that. So you choose one. Either you write this or that. Okay, so this universal set, subset, union of sets, and intersection of sets would help us to solve questions when given in an exams or on assignment. And this same is going to lead us to two-set problem, that is the Venn diagram. But the last one we need to know for today's lesson is complement of a set. And this is denoted by, let's say, if it is a set A, it is denoted by this. 1 on top of the A, that is A notation 1. A raised to the power 1. Okay. So what is complement of a set? A complement of a set deals with you comparing a particular set to the universal set. And what is in the universal set and is not in that set is what you write down. What is in the universal set that does not belong to that particular set is what you write down. Let's take an example. Okay, so students, let's take I as an assignment and let's tackle I. B complement. As I said, you compare it to the universal set. So looking at this, the bigger set here is A. That makes it the universal set. So we compare B to A. What is here and is not there is what we list down. So looking at this, 1 is not there, 2 is not there, 3 is not there. So that is B complement. And when we take IV, which is the C complement, we compare and we see that 4 is not there and 5 is not there. Viewers, this is how far the good Lord has brought us. We'll end today's lesson here and continue another day. Assalamu alaikum wa rahmatullahi wa barakatuh.